So you're in the session Process as Code and Introduction to the Electric Flow Automation DSL. Thank you very much for attending. I'm going to be talking about this new feature within Electric Flow, so the DSL. And for people who use Electric Flow, presumably this will be of great interest. But I think it'll also be of interest to a broader audience and an important theme for DUS in general, because it gives us the opportunity to talk and think about process as code. So we've of course heard of infrastructure of code thanks to Puppet and Chef, and I think we may be on the verge of having process as code available through this Electric Flow DSL. So you might also hear the term automation, automating the automation as well as kind of a theme. So I'll start with an introduction to myself after we run through the agenda here, and then we'll talk about what are DSLs in general, and why am I excited about Electric Flow's DSL in particular. I'll show you some use cases where I found the DSL to be of immediate value. So I've already had some experience with the DSL and really found it to be very useful for my day-to-day activity. And how this informs maybe a code-based software delivery approach and some benefits that would be realized from the use of code-based software delivery mechanisms. And then I'll talk about the Electric Flow DSL in detail, give you some idea of exactly how it works, and show you a couple of examples, and then lastly end with a little editor that we've created to ease adoption of this DSL. So first of all, I'm Greg Maxey, and this is me on Mars actually in Santorini, but it looks like Mars in there. And I've made a career of automation, so spent a number of years doing automation in a variety of disciplines, from test and measurement equipment to signal processing and analysis, system level design, system on chip, microprocessor design, and network testing or network equipment testing. So I'm now at Electric Cloud. I've been here for 5 years, and I am doing software delivery automation. And there is my Twitter handle if you are so interested. So now that you know about me, I'd like to know a little bit about you. So first of all, how many of you are involved in software delivery? Come on, it's a trick question. Everybody, right? Everyone. If you're at DUS, you're involved in software delivery in one sense or another. A little more nuanced question for you. So how many of you are using UI tools as your primary mechanism for doing that software delivery? Actually about, looks like 2/3, 3/4. And how many of you coding the automation? Yeah, about 1/3 or so. Okay, interesting. Do you automate the automation? A few of you, okay. So, how many of you are familiar with Electric Cloud? Heard of it? Oh, wow, okay, very good. Any of you users of Electric Flow? Oh my goodness, all right, well, okay, pretty homogeneous audience there in that sense. My job as a solution engineer at Electric Cloud is to work with our clients to rationalize their DevOps processes. So basically, helping them take their development, operation, and infrastructure tools and unite those into some form of automation, some way, such as a delivery pipeline or some mechanism for a repeatable, disciplined approach to delivering software, such as the one I've kind of shown here. So how do we approach the problem? So often we've got a whole bunch of legacy applications out there and software that needs to be rendered, presented to their end customers. And we've got some requirements in terms of what the business needs in terms of how that software is to be delivered, in terms of time frames, in terms of code quality, in terms of getting feedback to the developers, etc. So the question is, how do I take those requirements, the applications that exist, the applications that I'll be introducing down the road, and kind of turn the crank and come up with a well-tuned, well-oiled engine that allows us to go through and deliver software with the proper constraints, but also the proper quality, at the same time managing the processes across DevOps and infrastructure. So Electric Cloud provides the tooling for doing that. And so Electric Flow is the automation platform that I use to implement that. And what it means is I end up writing procedures, workflows, pipelines, and the like that integrate a variety of tools and to be able to present that automation, that process automation back to my customers. So part of the Electric Flow environment is to provide a modern user experience. So, dashboards and easy to use UIs, such as pipelines and release management pieces and deploy processes, and kind of drag and drop mechanisms for defining that automation. But I found a few situations where I run up against some limits to this. So an example of one of them I ran into recently. Sure, I could go ahead and drag and drop each one of those boxes and click into them and set the parameters and everything else like that. But at that point, I was thinking, I need some code. I really need to do this with coding rather than trying to do it through a UI. So that's what brings us to DSL. So let's first of all ask the question, what is a DSL in general? So in Wikipedia, it says DSL is a computer language that's specialized for a particular application domain. And this is in contrast to languages like Java or C++, which can be applied to any algorithm or problem at hand. So DSLs also could be subdivided into like markup languages, modeling language, specification, and programming languages. So let's look at a few examples. Actually, before we look at examples, Martin Fowler has actually written a book on this. I need to read it. I haven't. Has anyone read his book? Oh, excellent. I'll borrow it sometime. So, some examples. Everyone knows this example, HTML, right? So web page definition and text presentation. Anyone heard of MATLAB? Bet you got it. So for mathematical modeling, how about Verilog, System C, Lisa? Anyone ever heard of Lisa? So it's a language for doing microprocessor design that I worked on for a while. Regex, I guess everybody knows Regex, right? For text pattern matching. And then Make, right? Make, Ant, and all the various other languages used for build automation. And then lastly, the last example I'll show here is so chef recipes and Puppet manifests for infrastructure as a code. So that's really kind of informing this presentation. So infrastructure as code. So what about software delivery automation? So what's available for that? Anyone know what that is? No, okay. Ask me later on then. So why am I so excited about a DSL? Well, before I answer that question, let me introduce you to the inventor of the Electric Flow DSL, and indeed the inventor of Electric Commander, as Electric Flow used to be known. So this is the architect, Anders Wahlgren, who is our CTO. So I think it was about a year ago, he said, hey, check this out. I've written a DSL for Electric Flow, and here's what it looks like. And my first reaction was, wow, that's pretty easy. I think I could learn how to code in that way. And it's also compact. There's not a lot of syntactical goop around it, as you might find in other ways. It's declarative, right? To say, I want a project, I want a procedure, I want a step, I want a command. Just give me that. Not do this sequence of operations in order to get a step, but it's just there. It's idempotent. Ooh, kind of a new word, or not a word you hear in speech on a regular basis. So what that means is that you can run this, or you can apply this DSL and apply it again, and it won't break anything. Make a little change, apply it, and only that change will appear in your data model. Inheritance. So it uses the notion of closures to be able to say, this command is in the context of this step, which is in the context of this procedure, which is in the context of this project. So you've got this kind of notion of like a Unix shell, right? Or namespace. So it makes it also, that helps it be more compact and less verbiage to do operations. So what I found is it's very good for quick model creation. Just type it in. I can type a lot faster. I can type that code a lot faster than clicking on the equivalent user interface to achieve that. By comparison, how I used to code Electric Flow was I would use the EC Perl API. And so this is Perl in its finest glory. A lot of syntactical goop around it. The equivalent of that is here on the right. That's the DSL on the left. Actually, they're not equivalent. Because if you run this code as is a second time, it's going to blow up on you. It's not idempotent. Why is that? Because I'm saying create this procedure again. Well, the procedure exists, and you're not allowed to create a procedure once you've done that. Kind of the magic of the DSL is it knows, hey, that project already exists. Oh, he wants me to modify it. Well, I'll use the modify project API rather than the create project API. So let's look at a few examples where I've applied the DSL and found it to be quite handy. So recently I was working with a group that kind of, a little bit of old school here. So it was a configuration management team that was responsible for building some code, that is pulling some stuff out of a source code repository and eventually burning a CD so that they could put it into their highly secretive environment for whatever they were doing. And there were a bunch of steps involved here, and it meant they had to go putty into their VOB server, so this is clear case, do some funky stuff on that collection of files, copy those over to a local machine where they'd be able to do the builds, modify some files, do a build, and then start up a VM so that they could package this into an RPM, do a checksum, copy the checksum file and the RPM over to the build machine again so they could burn the CD. So pretty easy to actually implement that in Electric Flow, but it's a lot of steps, a jillion steps to do that. And of course, running on different machines. And again, it is something you can do in the UI. You can click through, add each of the steps. But I found it vastly easier, quicker to render this in a text editor and then just simply run it in order to generate that procedure. And also to do things like refactor it. Oh, I don't want one procedure, but I want to make this into 3 procedures. And that was very easy to do in a text editor. Another example, actually related to that previous example, is we had a situation where we needed to spin up a field deployable data center. So that means a standalone unit that can be put out in the field, not connected in any way to the internet, and hence the CDs that I was talking about. And so they need, in order to spin this up, they'd have to go into this field deployable data center, a trailer, open it up, fire up the machines, make sure the networks are working and do any configuration on the network, install some operating system patches, spin up some VMs, install some software, do a little bit of testing here, maybe add some more software, do some more testing, and then verify that all the pieces are talking appropriately. And so we were able to do that with a workflow. It was pretty straightforward, right? It's just a series of steps. There was a little need for some iterative stuff, and if something didn't work here, why don't you go ahead and try it again? But basically, it's a fairly straightforward linear workflow. Though you may notice that this workflow includes some hierarchy as well. So there's a subflows and also some pretty complex procedures. And one of those complex procedures was in the deploy piece. So it's calling the deploy aspect of Electric Flow. And that model involved a bunch of servers, or that deploy involved deploying lots of these services to a bunch of servers, right? So I have a pretty big matrix of stuff that I need to stuff into my model and finally get the right software into the right server. And that's where that diagram came from. So I had this big textual description of what I wanted, and here was the net result. So I ended up writing code that would parse this file and then generate that model as a result. Last example, also recently working with a bank that had many thousands of applications, tens of thousands as a matter of fact, but they had about 1,000 of them that were actively being developed. And they want to put these applications into a disciplined process, follow a kind of a standard approach to make sure the code quality metrics are collected in the right way or run, make sure that you've got a standard set of stages in the pipeline, but also be able to support different technologies. So there's a reality. We've got .NET, we've got Java, and we've got Xcode and some others, and we need to be able to continue supporting those legacy applications as well as bringing on other new technologies as they appear. But we want to be able to reuse infrastructure and technologies where it's appropriate. So use GitLab, for example, to do all the source control for those various those technologies. Make sure to follow a particular course in unit testing. It might not be exactly the same tools for unit testing, but have the same standards. Use a common artifact system. And again, as I said, have a standardized release pipeline, and then maybe have different deploy technologies. So the question is, how do you take 1,000 applications and stuff them into this particular discipline? And well, one answer is, okay, maybe I can create workflows and pipelines and procedures and parameterize them enough so that it can accommodate all of the possible inputs or combinations that this represents. Or alternatively, I can do maybe like the data-driven approach that I showed, and that's what we actually came up with. So they had a database of all of their applications that had the name of the application, where does the application live in source code, and a whole bunch of other attributes of that application. And also we'd want to overlay what is the particulars of the flow that we want to implement. So, how many stages, for example. And so this we rendered as a parameter screen, which could be then edited by the development team responsible for that application. And then from that would be synthesized or generated the automation that's necessary for each of those applications. So here's what happens when they hit the run button after modifying those parameters. And what you see is that we generate some procedures, generate the environment models and application models necessary for the deploy activity, generate the release pipeline, so it's defining the stages, and then a CI configuration. So when code is checked into that location I showed you, this the release pipeline would be initiated to do the build and subsequent stages of activity. And so what that looked like is it generated, this is what was synthesized for my application, just a dummy application here, and all of the procedures that are needed to support that application in a templatized form. And then here's the deploy model. So it had, in this case, we start off with one component in one tier, which has a very simple process associated with it. And the idea was that this would give the development teams a starting point for doing the particulars for their application. But they would be following the standard, the company standard in terms of the pipeline. And so we would do, at the development stage, do the code scan, the build, the deploy, make use of a snapshot to have a kind of a best practice here to make sure that as you promote to the various stages, you're using exactly the same process from stage to stage. So what this showed me was the power of DSL. So I got immediate benefit out of this, was able to do a great deal more work on site than I would have been able to do if I'd used other mechanisms. So I found that I was able to use it for kind of iterative development, the data-driven models, and also the ability to string together entire end-to-end software delivery processes. So what I think we'll see with the Electric Flow DSL for the enterprise in general is that it will offer these additional benefits. So provide a documented process, so a text-based representation of what your your process is, something that can be reviewed and discussed easily. And that same document is the executable. So it's an executable specification. So if you choose to say, nope, that's not what we want, we're going to tweak it in this way, we can just rerun it. So ease of onboarding of applications, the ability to utilize mature practices around code-based approaches, be able to manage very, very complex delivery processes, and also enable large-scale implementations. So developers, thousands of developers, thousands of applications, and also being able to match the right tool or the right interface with a particular user. So the people who are delivering this automation platform can be working with source code, but maybe their end users would stick to the UIs because they would be kicking off processes or making very small adjustments. Or maybe it's just for management purposes that they're only seeing dashboards or email notifications that they need to perform some action. So code-based approaches in general, these are some of the benefits that you get from those from using a code base as opposed to kind of maybe a UI approach to development. So you've got a very mature set of tools that are available. So you've got integrated development environments, Eclipse and Visual Studio and the like. And also version control, Git, etc. Best practices around modular design or library-based design approaches. You can use test-driven development approaches, or someone said developer-driven test, or whatever it was someone mentioned yesterday. Static analysis and other code quality approaches to enforce, to make sure that the automation is being written appropriately, is following standards of the organization. Ease of refactoring that I've already mentioned, so it was very easy for me to adjust just how the model was defined with the same functionality. Sharing and collaboration, so I just post my stuff up on Git and someone else can easily access it and reuse it. Scales well and enables, again, the data-driven approaches. So let's talk about the Electric Flow DSL in particular. So how is it implemented? It's based on Groovy. So Groovy is one of those languages that's particularly well suited to DSLs. It was basically one of the driving factors behind its definition. It has native access to the Electric Flow platform. So it's directly connected, it directly talks to the Electric Flow server JVM. And also it supports the entire API of the Electric Flow platform. And it enables both authoring, so how do I create a procedure or workflow or a pipeline, and scripting. So when I showed the example of the onboarding thing, is I used it to model the procedures that would be generated, but under those procedures, we're calling DSL to do some executions in a sequential manner. So you see it's doing two things at once. And probably as a best practice, you want to actually separate those. So in the case of modeling, you've got the idempotency, but in the case of scripting, that you might not have that. And then just as a reminder, the other benefits I'd mentioned before with DSL when Anders presented it to me. So ease of learning, compact, declarative, etc. And as I just said, you've got full access to the Electric Flow platform, which means you've got kind of the centralized automation platform and the robustness and the scalability and the security and all that comes with that platform. So let's look at a few examples. I'll show you the code examples for that configuration management procedure that I wrote, as well as the onboarding application, and then this spinning up new projects for training environments. So I'm going to switch over to Electric Flow here. Actually, no, I'm going to switch over to Notepad Editor, excuse me. So here's a sample of some DSL. And it looks very similar to some of the DSL I showed you at the beginning, where I have a project declaration. So I'm calling on a project, and within that project, I'm going to create a procedure, and that procedure here is the build and package operation, and then all of the various steps associated with that procedure. And you see on this right here constitutes a single step. So we've got the name, and then various attributes that are associated with it. So the command is just the command that is issued to the particular resource that we've identified here. And this could be a just command line thing, or it could be calling a procedure or another plugin. And you see I can just go in here and edit, just use a standard text editor or IDE to perform these edits. So in order to run this code, we use the EC tool command shell option, eval DSL, and then load this particular file that we're looking at right now. So to run it, this is what it would look like. And you see this is firing off, generating the procedure and all the various steps associated with it. Takes just a moment here. And the response saying, yep, it was successful. So we're going to see about our application XYZ inside of Electric Flow. So here's the Electric Flow UI, and looking at the project browser, we see the application, the particular procedure that we created, and there we have it. And with that one step and talking to the various different types of machines that were utilized in that runbook definition that we're working from. So in the case of the onboarding, as I said, the starting point was the definition of the application and the process that we wanted to apply to it. So we extracted from their database and rendered that as a JSON data structure. So with the application name, where the source lived, what artifacts do you want to generate from the build process, what build template do you want to use, etc. And so we had a top-level DSL program, if you will, or model that would parse in that information, so parse in that JSON representation and create a parameter screen from it, and then use those parameters for subsequent operations. So for the steps that generate the procedures, generate the environments and application model, and these I separated out as files. So I'm reading in files to do this operation. So we can see, for example, the procedure to the generation procedure is here, and generating the application model is here, where I'm writing the application to the default library and creating the app and app tiers associated with that model. I'm not going to run this top level one, but just show it to you in the context. So if I were to run it, it would generate this project right here. And this project has this one procedure in it, which we could run. And so now when we run it, we see that we see the parameter screen that I was going, so that I showed you before. So maybe we call this does 5, and create a new artifact, does, etc. And choose that it's a Java project versus .NET. And so now when this is run, what we will see is it'll go through and generate the procedures, environments, etc. Now if we look at any one of these, what we will see is that under the hood, it's running more DSL, right? So the DSL created DSL in order to run this particular, or define this particular procedure. And so once this is run, we'll have the complete end-to-end pipeline check-in mechanism in place. So the starting point for this is continuous integration. So if I refresh here, we see in our continuous integration dashboard that we have this new project right here. No runs have been performed of it, as you'd expect. We've defined the configuration, that is to look at GitHub or GitLab or whatever it was to query or to monitor that location, so that when code is checked in, we'd kick off the process. I'll just manually kick it off as if code had been checked in. And now that it's running, it has launched a release pipeline. And here is the pipeline in flight. And you see the first stage has actually completed. And within that stage, we defined a number of actions that needed to be performed. So we had to do code scan, the actual build, deploy it into the dev environment, create a URL to the application, and then lastly create a snapshot. So that snapshot will be used for subsequent promotions. And the way that the pipeline discipline was defined, we needed to have approvals between dev and QA. So we have an email that would be sent out to the particular user who needs to approve this, and once they've approved it, give their comments. And allow it to be promoted to the next phase, which in this case we defined as QA, where there are a number of processes or tasks that would be performed to accomplish, to achieve the ends of, or to do the QA testing. And this, in order to do this, the other model that had to be created was the application model. So if we look at the application models, we see here our DOES 2015 model, which was just composed of this one artifact or one component with its process, and then the application process associated with it, as well as the environment to which this would run. So we've got this dev DOES, we've got the production DOES version, and so this is what the environment looks like, targeting in this case, an application server, a Wildfly application server. So that's the onboarding mechanism. So you see kind of how I was able to get from CI all the way out to a production pipeline, or a pipeline that would take me all the way out to production in that flow. Last example is one that Laurent, you're here, yes, there. Hey, maybe I can get you to talk about it. No. So Laurent gives training in our products, and in order to give the attendees a real life hands-on experience with our tools, we often need to have very complex environments set up, right? We're deploying software to a number of machines. I've got to deploy to an application server, I've got to deploy to a database machine, and I've got a bunch of students, and they can't all be deploying to the same machine because there'll be collisions and all that. So he has to spin up an environment. He does it on AWS, where I've got a machine or a set of machines or an environment for each user. Now, could you imagine what it'd be like to have to go into AWS and spin up each one of those manually and configure them? And okay, you do still. Well, you should automate it completely.
No,
so once he's got.
I do imagine what it is.
Oh, you do imagine? Oh, I was going to say, please. I hope you're not doing that.
No, I don't.
So the idea is that all he has to do for a new class is say, okay, here are the users. What are their email addresses? And here's a list of the resources that I've got available from my AWS instance, and run this this DSL. And now each of these particular users has access to an environment, right? So they can log in as if they're logging in at work into Electric Flow and have an environment that's up and ready for them to use. This would be a huge project to do each time if you had to somehow do it manually. So thank goodness for DSL. The last topic I have for you is I've been showing you DSL in a Notepad++, which is a very fine editor. But we realized that it would be nice to have an IDE specifically for the DSL, for the Electric Flow DSL. So at a hackathon, a few of us got together and created one. And this is what it looks like. So you've got kind of this scratch pad where you can start entering in DSL. And so you can do things, Groovy. So if I just do a simple Groovy command here, you can see, okay, yeah, it generated the right answer and maybe a little fancier Groovy. You see that it generates some output. But what it does also is it gives you access to the full API of Electric Flow. So I can do things like one, see what all the things are, all the available commands are, and if I want to list all of the projects inside of Electric Flow, I can go ahead and choose that, submit the code, and it says I get an error. I guess I should have tried that before. But
no, it's because you asked for one project.
Yep, thank you. Good catch. Whew, thank you. And so there is the dump on the projects. Whew, glad you were there. And also there's some examples. So the example I showed at the very beginning, this kind of hello world example, where...
Can you increase the screen size a little bit?
So this hello world example that I showed before, so simply run that. And if we go back to Electric Flow, let's go and look at the projects here. We'll see that now we've got this hello project that's happily come up. And if we wanted to add extra steps, for example, we may say, hey, I want to go get an artifact out of my artifact management system. I might go ahead and see, let's see, artifact management. Go choose a procedure. I'm going to retrieve an artifact, and there are the steps, the code that's necessary to do that operation. So I've been using this regularly already, so it kind of has enough functionality to be useful. You know, you can save and retrieve the code, and as I've shown you, it gives you access to the various code. And if you don't happen to know, oh, what's the syntax for step, go ahead and click on that question mark, and it'll give you the full dump on the help documentation for the step command, for example. So all of this is available actually on GitHub. So if you are so inclined, you can get some samples of DSL out on GitHub. So it's out on Electric Cloud-DSL samples, and the editor is also available out on GitHub. So it's a plugin. So if you have Electric Flow 5.4, I think, or beyond, you can go ahead and try this out. And please, if you want to enhance it, that would be great. And to wrap this up, just a few concluding remarks. I think what you've probably seen is that, you know, Electric Flow, kind of a great environment for doing the visualization and medium scale content authoring for automating the automation. But for larger scale tasks, the Electric Flow DSL has some great advantages by giving access to the full platform and also enabling this code-based authoring or process as code mechanism. So that concludes. Questions, thoughts, comments? Yes?
First, if you already have existing procedures and projects, can it dump it into DSL format?
So the question was, can I generate DSL from an existing model? And the answer is yes. So there is a generate DSL API that's available. Question back. Can you use DSL in dynamic procedures? Absolutely. As I say, you got full access to the API. I'd have to think about it, exactly how that would work, but yes, you have the control available. I'm going to have to try it. Actually, there's a question here. Let me get this one.
So the command steps that you have been showing, or the values inside the command are kind of very simple. What do you do in cases where you have, you know, complex code inside of that? How is that handled?
So the question was, I've kind of shown simple examples here. So like my command line was just, you know, kind of echo this, blah, blah, blah. What if I have more complex structures in there? So for example, if I have a shell command that has $signs and other things that might clash with Groovy, for example, how do you manage that? And so there are really two mechanisms that I've been using. One is you say, okay, well, I want to be able to insert something like this, you know, my input. And if I run this, DSL is going to complain. It says, hey, $sign means something to me. Excuse me, Groovy is going to complain. So you can escape it. So that's one mechanism. The second mechanism, a little bit cleaner, if you're, say, you want to instantiate some Perl or DSL code or some other language, is to save it in a file and then reference the file. That's another. Did that address it, or is that not what you were referring
Well,
to?
I think more kind of that second point. So, I mean, I don't want you to go, but do you have like an example of how you would reference an external file?
Yeah, so that's actually one of the things that's available here. It's a little bit tricky. I should say here, load a value from a file. It's right here, is saying, okay, I want to say, in this example, is saving, creating a property called test. And here is the call to the file. So it has this kind of funky syntax. It's basically, it's Java. Groovy and Java are really one and the same because they're talking to the JVM. And so I just basically would load this file. The caveat to it is that file has to be on the server, on the Electric Flow server. So we probably need to find a more elegant way of doing it so you can do on the client side as well.
So in the case, I'm sorry to keep beating this, but in the case of that example, you would have command equals new file, and then the file.
No, I mean that's.
Kind of load in.
No, that is the syntax. Maybe it's clearer if I separate what's going on here. So there is this command property, which is just create property. And if you look at the API for that, oops, I didn't mean to submit that. If you look at the API for that, I clicked a button, so it's off doing something. The API for create property includes the ability to set the value, and so what follows is going to generate a string, basically, a return a string. So it's going to open that file and pass.
So what he's asking is if you can do the new file following the command colon in your step directly.
Say it again?
When you define your step, you have
Yeah.
a command.
Yeah.
And instead of putting your string there, can you put the new file?
Yeah, no, yeah, as I said, this can be anywhere that you're expecting text. You can use that exact same syntax. So in fact, if we look at this onboarding procedure, I'm in fact doing just that. Because this is Groovy that I'm loading, it would be kind of funky to instantiate Groovy inside of Groovy because I'd have to escape all the, so better do a file approach. So there's a question, where'd you go? Oh, all right.
Along the same line, so where on the command server does that file need to be stored?
Where on the?
The commander server, does that file need to be stored?
No, it doesn't have to be stored in any particular location. It just has to be on the files. It has to be visible to the flow server.
Okay, so I can drop on network shared.
Yes, absolutely.
If you want to run the DSL through a procedure, is there a way to have it run native, like through the shell you can designate Groovy or something?
Yes, and in fact, that's exactly what you're seeing right here. So shell, you see how I've defined shell? And it is running, this is the command line equivalent. So it's saying, whatever is in this, returned in this text block, push out to here. And so that's the syntax for using a different shell. So instead of using the native, say bash or CMD, it's using the DSL. Can you see that? I don't know if you can see it. Maybe I should zoom in. There we go. How about that? Do you see the syntax for shell? So the shell field will take any command line. So I'm using the EC tool, evaluate the DSL, and then say what file am I going to load, and this is the syntax for substituting in the command block for the to be supplied to the file API.
So Mark, now then, we also have a training module on DSL. So come and talk to me and I'll give you a copy.
Questions from this side? Oh, yes.
Since you use EC tool in there, does that depend on the EC Pro?
So there's a question. Since I'm using EC tool right here, the question is, does it depend on EC Perl? And EC Perl, actually, I'm going to ask someone who knows the tool deeper. Tane, do you know? I don't think EC Perl is involved at all.
Yeah, EC Pro shouldn't be involved. With EC tool is a compiled binary.
Yeah.
So I'm trying to get away from the Perl 588 and to be more platform independent.
Yes. So you are,
So I can use that really well.
DSL will get you away from EC Perl. In fact, I haven't touched Deep C Perl in about 6 months as a result.
So if you run it externally to Electric Flow, does it mean that you need to do a login with the EC tool?
Yes, it does need to. Well, Actually, in the context of a job step, you're already logged. If you do it externally, yes, you'd need to log in. And in the case of this editor, we're using REST. So of course you have to log into the server through the REST API. Yes, another question.
Related to what I asked before, like because you need to log in, like if I run on a server that doesn't have Electric Flow installed on it, like on a separate machine, so I don't have access to EC2. So is there a way I can connect to this?
So the question was, I'm going into a machine that has nothing to do with Electric Flow. How can I get access? Well, there are two answers, I think. One is you can install the EC tool, right? You can install it on that machine. And the second is you could go through the REST API using like this mechanism. But does that answer it? Or Tane, any thoughts?
Yeah, no, I think that the REST API, so there is eval DSL supported over REST?
Yes. Yeah, in fact, that's what we're using for this UI.
So we can mix both of them, DSL and REST?
Sure. Yeah, you can make REST calls from the DSL.
Yeah. You have all of the above, basically, over REST, which is any mix and match of however you want to mix DSL and agile commands.
This is available. All this is available starting from what version?
Is it? It's 6.0? Oh, thank you. All right. So the question was, when is this supported? It's stand corrected. It's 6.0 and beyond. Yes.
Can you export workflow definitions?
Yes. Sure. Any object.
Any object. So it could actually be used to retrieve things you want to move from the and SDK environment to the production environment.
Sure. As opposed to using the XML. You could. We'll probably want to refine that. I'm not sure that'd be the best. I would. Yeah. I think.
Yeah, you should be able to generate DSL and then evaluate that on the production server. Although, you know, if you're moving towards DSL, maybe if you're using that as your mechanism, it might be a good approach to be using DSL on your dev server as a, you know, if you want all your definitions to live in code in the first place, then yeah.
On a previous slide, you had Electric Flow or Electric Cloud UI, and you're comparing it to DSL. Is the UI portion of your product have versioning, or do you have to go from DSL in order to be able to do versioning and seeing what's changed between your?
So the question was, I think, fundamentally, is DSL really the only mechanism for providing versioning within Electric Flow? And no, in fact, there are three mechanisms available. So there's the DSL gives you versioning because you just check it into GitHub. The second is you can do exports, so XML exports and version those. And the third is the UI is versioned. So you know, if you look at any
Is it versioned in a way where you can easily see differences, or is it just slap a number on it and say this is version 2 of the?
So change tracking, which is introduced in 6.0, yeah. So the change tracking basically does exactly what you're asking. It tracks everything, and then you can diff, you know, step command blocks and the like in the UI with like actual visual diff tool that like what you're using.
And that's the part we've seen other ones that say that yeah, we can version, but all it's doing is this is version 2, this is version 3. You say, well, what's the difference between version 2 and 3? And it doesn't tell you.
no, it should.
I bet, you know, maybe not right now live, but we could quickly show you what it looks like to diff something. Just change a step command and diff it. It's pretty straightforward.
Yep. Questions? More? Anything else? Oh, yes.
If you can already import XML files or JSON files, what are the big advantages of a new language for DSL?
So the question was if you can already import XML, and you also said JSON, but what's the advantage of having DSL? So I don't know if you looked at the XML. I don't want to be writing XML. No.
JSON, I'm not sure if we did our own.
You must have done. Yeah, we don't have. We can generate JSON for some actions, but we don't have an import mechanism. It's easy enough to write one, and in fact, I kind of did. You saw in one of those examples.
So the benefit of DSL really is because it's Groovy-based, it's actually, you can write code, right? So you can program in it loops, you can read data, etc. And that's not something you can do in an XML file.
It's not details anymore, like that is really what you want to have integration management.
And that right there is another big advantage of DSL, which is it is a much higher order construct than what you talked about. Like you need to know the lower level schema of the product when you're interacting at that level. The DSL, all of that is just hidden. That's the big benefit, which is so you can achieve the same thing with both the means, but the DSL is a much higher order construct.
And you can do things in DSL, as I say, with as a scripting language. So here's an example where we use the get projects API, which I showed you, which is dumped JSON, right? Just dump the JSON data structure. Well, I can use the DSL's built-in functions. There's this each, I don't know if you'd call it a method or what it's called, but each will iterate through each of the elements in an array. And I say, well, I want to grab the element in the array .name, so that field in the array, and I'm building up this list, just syntactically, right? I'm taking that individual element, adding a line feed, and then eventually return that, and you can get something that looks like this. So I've just dumped out the entire list. But the point being is that you've got access to the full scripting capability of the language. So both the APIs for Flow and then the syntax or the scripting capability of Groovy. And a lot of other stuff that you can do, right? You can build your own classes and things like that. I haven't really experimented with it, but you got actually the full power of Java behind this as well. Further questions? Oh, one more. Is it possible to customize the UI with this? I don't know.
I mean, like Microsoft did with the XAML.
Oh, with YAML, it's a great question.
You can do some of it. So, for example, you can change the view and the tab. So that's something you can do with the DSL. If you're talking about a dashboard with JWT, I doubt.
Yeah.
It depends really on how you design whatever extension. So the Flow UI has the ability to extend with the SDK. Right now, if that SDK is data driven and it consumes a YAML file, and that's what it uses to then paint whatever's on the screen, then you've essentially done that. That's outside of the scope of the DSL a little bit, but the same concept can translate over.
And we're still a little bit new to it, right? These are new days, so maybe we'll figure out how to extend it in that way. Yeah, another question.
So could you put the DSL definition in a plugin if you wanted to?
Absolutely. Yeah. So the question was, can you put the DSL definition into a plugin? So what is a plugin? So plugin can be just a project, and so the project can contain steps that contain the DSL. Is that kind of what you're getting at, or something more? Or you can store it as properties, or
I think it might be properties. Kyle, I think your question might be if you want one of the DSL files to be something that your plugin provides a procedure layer on top of, or something like that. Maybe not.
Yeah, kind of. I was thinking more kind of like where, like the plugins right now, basically that definition of that project, right, that plugin's going to create is going to be an XML structure. If you could replace it with this, or if you could just essentially put it in as a property and then have some sort of promote action or something that would actually execute the DSL.
So I think actually that the DSL might be a separate, a different way of what you're doing with plugins today.
Right.
Which is actually design your plugins using DSL, and then you don't even need to wrap things as a plugin per se. You can wrap all your procedures and projects and stuff like that in code, process as code, right? In code, and then simply evaluate that DSL on your dev server and make sure that it works, and then evaluate it on the prod server. So you're using plugins in a way right now that DSL might obviate the need for.
Ah, interesting. Any other questions? Going. Oh, one more. Oh.
Do you see the DSL being used for scripting everything? So even scripting the scripts inside of the steps, etc.
Yes,
So
yes.
if that's the case, or that will be the case for some of us, how should the UI change? Because we're not editing inside of the UI anymore now.
Ooh, yes. Okay, so the question is, do I envision DSL being used to script everything? I think within Flow, and then the question is if you do that, how will that affect the presentation in the UI? Well, the little secret is that you can actually change the data model in ways that the UI won't know about. So.
And then let's ask that. So the UI, the UI is serving multiple purposes. First one of them is authoring. You can come very close to authoring much of your definitions in DSL and not really leverage that of the UI there. But UI is also, a lot of the UI is about monitoring, executing, tracking, troubleshooting. And that's where you'll still need the UI.
Yep.
You still need to go to your job details, see those things and see all the log files. So it will be a combination that you'll need to figure out. On authoring side, it's conceivable that you can pretty much author everything outside, but there are some of the customers here who are, even without DSL operating in that way, all of it just gets generated. They never come to the procedure authoring. So yeah, it's clearly conceivable, but UI itself is having a lot more purpose. It doesn't work.
And I think what you're going to see is maybe situations where all of the authoring is occurring in DSL, and the presentation, depending on the particular user, might be in a custom UI like this, that's built up out of REST calls, right? So you're not using the API. So I see kind of a mixture of those. And there's also a question you may be thinking, what about all those plugins we've got? You know, those are all written in EC Perl. Can we somehow get away with that? Well, you know, maybe, you know. Or we can, certainly the newer ones will make sure to render as REST or as DSL. Oh, one more.
So you kind of broke my brain a little bit with this one. So I keep, throughout the conference, we've been hearing chat ops. So what I was trying to wrap my head around earlier hearing that is kind of, well, how would, if I had a bot, like how would I ask it to go tell me, hey, you know, Flowbot, what's installed on this environment? And it seems like you could use the DSL then to kind of do almost like these ad hoc queries on stuff, and because I was trying to figure out, well, how would you execute that, and then you'd have to go like put it in a property and read that property out, or
You know, as you saw, you don't need to do that.
right? No,
Yeah, exactly.
You're showing this, and it seems like it's kind of opening that scope now that, you know, it just will return a text.
So the bot, you might say, oh, EF DSL, get projects or whatever it is, and it, maybe you do some of this other syntactical stuff to refine the output. Yeah, I can imagine you doing that as well. Or you probably want to package things up and say, okay, I have this little procedure or that does this operation for me, run this procedure.
You can want to
Like it's just a REST call.
Yeah,
Yes.
REST call probably would be a, depending on what you're trying to do.
Well, so basically to ask it a question, right, that I wouldn't have to parse. So I would want to say, tell me what version of this is on this is on this environment or this
Exactly.
resource.
For such a pointed question, if there is a straightforward API available, then it might be easier using a REST interface. But
But then I'd have to parse the JSON
Greg's answer is-
or the
Yeah.
versus if I do this, if there's a way to pass parameters, it just spits out the answer, right? Version 1.2.3 is out there. Okay,
Yep.
thanks, chatbot. You know.
So do a Wolfram Alpha call on this. They give me this, or chat ops or whatever it is. And so we need like another layer here that's able to do kind of human language parsing.
Well,
and
not
yeah.
necessarily. Yeah.
Right.
The results back and do something with the results and present it in a more.
Yeah.
All right. Last chance. One. Thank you very much. Enjoy the rest of the show.